Alright, so here's problem 1. Well, BC is perpendicular to CA, so that means there is a right angle at C. We're told that BDC is 39.85 degrees. We're told that CDA is 60.53 degrees. We're told that CD is 1,024. We want to find the length of AB. Alright, there are a few different ways to do this, but what I like to look at is the fact that I have two triangles. Alright, so I got C, I got D, I got B, I got C, I got D, I got A. In both these situations, CD is 1,024, but they have different angles. So CBD 39.85, but CDA 60.53. And what I want you to realize is that we have right triangles, so we could set up SOHCAHTOA. I've seen people use law of sines, I've seen people use law of cosines. This is the easiest, this is the most direct way to try this problem out. So what do I want to solve for? I want to solve for these two sides. Alright, so I'm going for both of them tan. Tan of 39.85 equals opposite over adjacent. Over there, tan of 60.53 equals opposite over adjacent. If I cross multiply, y equals, for this one, 851.34, well, y over here equals 185.29. Now overall, we have to remember, what is this problem asking for? It's asking for the length of BA. But what I just figured out is that I know that CB is 851.34. I also know that CA is 1805.29. So how do I get AB? AB equals 1805.29 minus 851.34. And that gives me my final answer for AB. Obviously not drawing the scale, but that's what I get in that situation. So even though there's multiple pieces going on, keep it simple. It's a SOHCAHTOA problem. Alright, the ship problem. So we've looked at this, but I really want to make sure we're okay with this problem. Alright, so a ship was approaching. There's my little boat. The captain measures the angle of elevation to the top of a cliff to be 37 degrees. Alright, they sailed 2650, and from there they looked up again. In this situation, we had 49 degrees. Okay, so now what we need to figure out here is the captain measures how far was the ship from the cliff. So we're looking to figure out this whole thing and how high was the cliff, this whole thing. Alright, so two-step process. So if this is 49, this is 131 degrees. 180 minus 37 minus 31 leaves us with 12 degrees. Right, so I want to solve for this piece. By solving for that on the left triangle, I then have something for the right triangle. So what can I do? Law of sines. 2650 over sine 12 equals x over sine 37. I cross multiply, I solve, I get in this situation, I get x to be 7,670.61. So by doing that, I've just set up a basic SOHCAHTOA problem. I need how far up the cliff this was. So from this standpoint, I got sine. So sine of 49 equals opposite over hypotenuse. I cross multiply, I solve. Up the cliff, we're talking about 5,789.08 feet. Right, that's what's going there. Now, the other thing we could do here is, we know that this is 2650. If we could figure out this, we could add that to 2,650 and get the total distance. So for this problem here, what we could do is, we could solve using SOHCAHTOA again. 49 degrees, 7,670.61, and we could solve for this. Alright, so if I set up my SOHCAHTOA for this one, I got cos of 49 equals adjacent over hypotenuse. Alright, so I throw it over 1, I cross multiply and solve. What do we got? 7670.61 times cos 49. Alright, so I get 5,032.37. Alright, so that's what's here. So if I want the overall final answer of how far was it at the start of the problem, I add that together, 7682.37. That's our final answer. Alright, so we saw this problem already on the exam. You know, I was hoping that, hope it went well. So I'm just throwing it out there to make sure we're really okay with this. Last upper level problem I got is here. Alright, given the following, solve for x. And I'm even going to add to this. Find the area of this quadrilateral. Alright, so if I'm looking at this, I can call this section 1, I can call this section 2. So right away, section 1, area equals 1/2 20 times 15 times sine 100. Alright, so instantly, I can get my area. 0.5 times 20 times 15 times sine 100. So I know the area of that piece is 147.72. Alright, so I'm halfway there. Well, I need more information to be able to find the area of part 2. So I either need angle x, or I need that side running right along the middle of that quadrilateral. Well, if I wanted to, I could figure out, call this W. I could figure out W by doing law of cosines. W squared equals 20 squared plus 15 squared minus 2 times 20 times 15 cos 100. Type that into my calculator. Take the square root of it all. And what do I got? Let me check. 20 squared plus 15 squared minus 2 times 20, 15 cos 100. Right? And I take the square root of that number. And I get 27.00. Alright, good enough. Alright, so with section 2, I could find the area now, right? But I could use Hero's formula. So S equals half the perimeter, which in this case, 25 plus 27 plus 10. Half of 62 which is 31. 31 times 31 minus 27 is 4. 31 minus 25 is 6. 31 minus 10 is 21. And that could give me my area. 30 square root 31 times 4 times 6 times 21 equals 124.99. I was going to call it 125. So the overall area of the entire problem, 125 plus 147.72, is 272.72. Now I know it didn't ask for that, but I wanted to do it anyway. All right, finishing this problem off, we got to solve for x. How do I solve for x here? All right, again, law of cosines. 27 squared equals 10 squared plus 25 squared minus 2 times 10 times 25 cos of x. Right, so 27 squared minus 10 squared minus 25 squared gives me 4. Right, so 4 equals negative 500 cos x. Right, so I got 4 divided by negative 500 cos x. Inverse of that and I get my angle to be 90.46 degrees. Done.